Here we got a basics practice, and step one, first one is factor completely 8x squared minus 72. So I guess I need to make up something similar, which will take me just a moment. It's going to be a lot bigger. Anyways, here's one. This one's way harder than this one. This is 99x to the second minus 396. Here's my similar, okay? So what I'm going to do is I'm going to focus on what I can pull from each piece. Turns out I can pull an 11 from both. If I pull 11 from 99, I have a 9x squared left. And if I pull it from negative 396, I have minus 36. I can actually pull some more out of this one. I don't know why I didn't do this, but I'm going to pull a little more. I notice that both pieces are now divisible by 9. 99x squared minus 4. It makes a difference, because had I not realized I could also pull a 9, this would have been 11 times 3x minus 4 times 3x plus 4. That's not a complete factorization. But if I realize I can pull the 99, I'm x minus 2 and x plus 2. This is the best one. Solve x squared plus 72 is 0. That's what you have on your practice sheet. Let's make it 78 for my similar. Subtract. X squared is negative 78. Counteract squaring. That gives me x equals plus or minus something. Now, when I talk about the root of negative 78, I treat it as the imaginary root of 78. Factors of 78. This is not the right one. 76 is the number I want. Factors of 76 would be 4 and 19, and the root of 4 is 2. 2i root 19. Sorry, I had to change it. 2i root 19. Full answer. All right, another factoring one up here. Let me make up something else. So the similar example here is going to be 35x squared minus 9x minus 18. Now, the key here is you're basically reversing FOIL. That's what it is. It's reversing FOIL. You reverse the FOIL method. And what I mean by that is you think about what goes here and here. Those two pieces make 35x squared. Well, 7x and 5x. If you guys are anything like me, you had to learn your multiplication tables in 4th grade. 7 times 5 is 35. What goes here is going to be, has to force becoming negative 18. And I'm just going to do 3 and 6. All right? And I'm going to check it. The inside right here would make 15x, and the outside would make 42. 7 times 6 is 42. This isn't going to work. I have a goal of 19. So, guessed wrong, try again. I'm still going to stick with 7x and 5x. What I'm going to do is I'm going to swap the 3 and the 6 around. Oh, sorry. 6 there, 3 there. This will make 30. This will make 21. And if I do 21 minus 30, I'm in business. So I guess and I check. All right, I've been over that. Here's your factor, 8 cubed minus 23 cubed. Let's make this 12 cubed minus 25 cubed. And all you got to do is know your pattern. A cubed minus b cubed. Factors as a minus b times a squared plus ab plus b squared. That's about it. So a is the first thing you see that's cubed, it's 12. B is the second thing you see that's cubed, it's 25. And then I plug into this guy right here. 12 minus 25, 12 squared, plus 12 times 25, plus 25 squared. And I stop. I don't do anything else. That's it. Here we have solving a factored polynomial. All you do is you use that cover-up technique. You take each individual factor and you set it equal to 0. 2x plus 7 is 0. I forgot about the first one. X minus 5 is 0. And 18x minus 1 is 0. Then you do your two steps, kids. 2x is negative 7. X is negative 7 halves. Apparently I'm solving this one as it is. Forgot to make a similar. That one's easy. X is 5. Two-step on this one. 18x is 1. X is 1/18. Those are simple. 2 out of 3 of you will miss it. Don't understand it. FOIL and show your work. Let's do 4 minus 3i and then 5 plus 6i. 4 times 5 is 20. 4 times 6i plus 24i. Negative 3i times 5 minus 15i. Negative 3i times 6i minus 18i squared. And I know that I squared is negative 1. So when I talk about negative 18i squared, I'm really talking about negative 18 times negative 1, which is positive 18. So 20 plus 24i minus 15i plus 18. Combine like terms. 20 and 18 makes 38. 24 minus 15 makes 9. Order matters. By the way, kids, it aggravates the crap out of me. You still have to show your work, but like, this is the easiest thing in the world to check. You can literally type in and see if you're right. Oh, I was. Who'd have thunk? Number 7, solve using the quadratic formula. Always simplify. Quadratic formula goes x equals negative b plus or minus square root. Oh, I'm off tune today. B squared minus 4ac all over 2a. All right. A, B, C. A is 4. B is negative 7. C is 7. Plug in and go. Opposite of a negative 7 is a positive 7, plus or minus square root. Some of you guys are not dropping the negative symbol. If you don't drop the negative, you better wrap it in a set of parentheses. Minus 4 times A, which is 4, times C, which is 7, all over twice of 4. And then crank out the numbers. All right. If you can't figure this stuff out in your head, you just push buttons. Let's just assume that I can't figure it out. Inside that radical is a negative 63. Both pieces are over twice of 4, which is an 8. 2 times 4 is 8. 8 broke the fraction apart. So now I'm thinking about that root of negative 63. It is the imaginary root. Factors of 63, again from 4th grade, 9 times 7. Root of 9 is 3. 3i root 7. So I'm sitting at 7/8 plus or minus 3i root 7 over 8. Fully simplified. Number 8, using synthetic division. Right here, if x minus 2, then x is 2. Put a 2 out front. Always change whatever sign you have and put it there. You've probably done this one before. There is a gap between 2 and negative 3. There's a 0x cubed that's missing. I drop, and then I multiply and I add for eternity until I'm done. 2 times 2 is 4. 0 and 4 adds to 4. 2 times 4 is 8. Negative 3 plus 8 is 5. Twice of 5 is 10. Negative 5 and 10 makes 5. Twice of 5 is 10. Sums to 6. Make sure I didn't make any mistakes. I feel good about it. Remainder, constant x, x squared, x cubed. So it turns out that this is 2x cubed plus 4x squared plus 5x plus 5 plus 6 pieces of x minus 2. 9, we got average rate of change. Oh, I did the whole thing. Man, I forgot to make something up similar. I did that on 7 and 8. 9, let's just make the interval -2 to 4. We're going to do f of b minus f of a over b minus a because that's the formula for average rate of change, and we're going to plug stuff in. To find f of b, I will take a -2, I will store it to x, and then I shall type in this function. Some of y'all are starting to get calculators out of the library. What you have to do for exponents that have more than one piece is wrap them. They're a little bit different. I got something funky. Ugh, it's ugly. Of course it's ugly. I got -3.3210. Now I'm going to take a -2 and find f of a. Up, 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 up. Enter, enter. And I got another something ugly, -3.3. Oh, Milbrath screwed up. My f of b is wrong. I was supposed to plug in a 4. I do that from time to time with average rate of change. So let me repeat that. 4 store to x, 1.875. And I accidentally did my -2 ahead of time, -3.3210. And I'm good now. 1.875 minus a -3.3210, sitting pretty over 4 minus a -2. If you want to do that all at once, hit math number, numerator over denominator, 1.875 minus a -3.3210. Oh, let me do that again. Math number, numerator over denominator. I was hitting keys and I wasn't looking at what was on the screen. That's going to be over 4 minus a -2. Pretend I don't know what that is. There you go, 0.866. And it is an approximation because I rounded. It's as far as I can carry it. And I need to stop. Hopefully I got enough done where I can finish the rest of it before I leave school today.